Hello everybody, my name is Halo. Welcome to this series where we're solving Codeforces problems in Python. We are doing the A to OJ ladder, and in this video we're going to be solving problem 110A, which is called nearly lucky number. This is a problem where the question is quite twisted, but the solution is actually quite simple. As you can see, I spent a very long time when I actually initially tried to solve this problem, and yeah, I just needed to look at it from a different angle. It's actually quite a simple problem. Let me tell you how to solve it. Right, so as always, let's just go ahead and read through this question once before we attempt to solve it. We're saying Petya loves lucky numbers, and we know that lucky numbers are the positive integers whose decimal representations can only contain the lucky digits 4 and 7. What this means is a lucky number is any number where there is only 4 and 7 in the digits. Okay, so anything that is other than 4 and 7, if it's there in the number, it is not a lucky number. Okay, so and they also say, unfortunately, not all numbers are lucky. Petya calls a number nearly lucky if the number of lucky digits in it is a lucky number. So we already know what a lucky number is, and we're saying that the number of lucky digits will be kind of like an integer value, right? So that integer, if it is a lucky number, we call it a nearly lucky number. What this main number? So let's just take an example to see what that looks like. So let's take this problem. Okay, so 774 7774. So first things first, is this a lucky number? Lucky number, yes. So few things to keep in mind is lucky numbers can also be nearly lucky, but not all nearly lucky numbers may be lucky numbers. Okay, we'll take another example for that too. Okay, so let's just count the number of sevens, the number of fours. So these are all lucky digits. So every digit is a lucky digit. So that means 1, 2, 3, 4, 5, 6, 7. There are totally 7. This is the sum of lucky digits, and the lucky digit is represented by 4 or 7. Okay, so 7 is definitely a lucky number, yes. So this is also a nearly lucky number. Okay, and one more, let's take one more example for here. In case there is 40047, there is totally 3 lucky digits. 3 is not a lucky number. Let's just say there's another 7 here. In that case, it'll be a 4 lucky digits. It'll be a nearly lucky number, yes, but it will not be a lucky number because there is 0. So only 4 and 7 should be there. Okay, so if you're able to understand that, I think rest of it is quite simple. How we're going to be doing this, how we're going to be approaching this problem, and how the code is going to look like. Some things to keep in mind here. It says this value n, that is this line right here. They're saying it's an integer which can be up to 10 power 18. So as you can see, your computer can only handle tasks up to 10 power 8. So that will be, I think it's 10 power 8 processor per second or something. So in case of very high numbers like 10 power 18, doing mathematical calculations on it will not be something that you can do in a short amount of time. So by default, mathematics is out of this question. So this also means, what is 10 power 18? That is nothing but 1 followed by 18 zeros. Okay, so total the number of digits will simply be 19 only, right? And 19 is something that you can easily work with strings. So this definitely has something of a string solution. So that is a clue that you can take. How do you solve this using strings? First of all, let me just break down a question for you, and let's just try to solve that. Okay, so let's take this scenario itself. Let just assume this 774 774 followed by a 0. Okay, so first things first, we know that the lucky digits are either 7 or 4. So what we can do is, we can just iterate through every element here, okay, and count the number of lucky digits. So in case it's a 7 or 4, if 7 or 4, just increase a count by 1. Initialize that to 0. Once you iterate through everything, you'll have the number of lucky numbers, right? So in this case, it'll be this part, this part, this part, this part, this part, and this part. So totally there'll be 1, 2, 3, 4, 5, 6. Okay, so there are 6 lucky numbers. Okay, then you have to check if this value is again a lucky number. And how do you do that? First of all, convert this integer 6 into a string again. So now it will be 6. Okay, now just iterate through this every element of that string and check if there is something other than 7 or 4, because you've said if anything other than 7 or 4 is there, just go ahead and declare it as unlucky. So unlucky is nothing but no. Okay, so no will be for the nearly lucky number, which is checking if this particular value, that number of lucky digits, is lucky or not. Okay, and I know this whole lucky not lucky thing is a bit confusing, but I hope you stick with me here, because that's it. That's entirely what it is. We're going to iterate through all of this, count the number of 7 or 4s. That will be common only. We take that value and see if there is something other than 7 or 4 in that particular number, in the digits of that particular number. If there is nothing like that, we can go ahead and say that this original number is a nearly lucky number, else we can say it's not a nearly lucky number. That's it. So let's say if there's other extra 7 over here, this integer value will now be 7 instead of 6. 7, there's only 7, which is either 7 or 4. In this case, this number will be a nearly lucky number. And let's say in this case, this number by itself is lucky also, but that is not something that we need. We just need the digits and that value and checking if that is lucky or not. It does not have any issue with the main number being lucky or not. Okay, so I hope you're able to understand. If you're not able to understand, stick with me to the code, you'll be able to understand it. Then let's move on to the code, guys. Right, so coding this is very, very simple. First things first, as we know, this is what the input format is like. So when you know, you get a string, right? So that's it. So let's just take the input, st is input, done, and then let's just initialize count to be 0. This will be counting all the lucky numbers in that particular number. So first things first, we have a string input, which means we can go ahead and iterate through the string. So let's go and iterate through all the elements, and let's just check if I is either 4 or I 7. Okay, in that particular case, what we'll do, we'll go ahead and increase this count value by 1. Okay, and once this is done, and once this loop is completed, we'll have some value for the number of lucky digits, right? So now we need to check whether the CT value is lucky or not. How do you do that? First of all, convert that into a string. So CT will now be string of that value. Okay, and let's just say initially we can assume that to be a lucky number. I'll tell you why this is better. What we can do now is we can iterate through again all the elements of the CT and say if I is not equal to 4 and I is not equal to 7. So I is something that is other than 4 or 7. In that case, we can just go ahead and say this status to be no, and then we can break out of this loop. Since we are doing this part here, we can just abruptly stop it anywhere if there is a 0. For in this case, okay, not here, but anywhere in our number, let's just say this is the number of lucky digits. And that's how that works. It saves a lot of time and it makes our process a lot easier. So, and instead of doing 2 of these not equal to, you can do something called not in, and you can produce something like a tuple. And I'll tell you a short trick also. You don't even have to do this in case the string. You can just go ahead, create a string and put these 2. Okay, so if that I, some other digit than 4 or 7 is there, we'll just go and say this is what the status looks like. Okay, so now that is done, we can just go ahead and print this value of the status to get our answer, and you can see all cases have passed. Let me just go ahead and submit this also so that you know that this is the right solution to look for. I hope you're able to understand what we're doing here. We're just counting all the digits which is lucky, and then we're doing a check for whether that particular number is lucky or not. We assume that it's lucky, and in case we encounter at least one case where it may not be lucky, where there's something that is other than 4 or 7%, we just break out of the loop. We say yes, this is not a lucky number. We set the status to no and print that. Okay, so as you can see, it got accepted. Thank you so much for watching. I hope this video helped you. If it did, hit that like button. I'll see you in another video. Until then,